Up next, let's welcome Prasanna Venkatesh, Innovation Head at HCL ATSS Wave 4 IoT Lab, Riyadh, Saudi Arabia. As a passionate technologist for the last 2 decades, Prasanna worked on building innovations in the field of AI, mobility, cloud, and IoT areas. He was the founding member of the Insurance Innovation Lab at HCL and helped run the SaaS mobile initiative for the Ministry of Communication and IT of Oman. He currently heads the HCL TSS Partnership Wave 4 IoT Lab in Riyadh, Saudi Arabia. He is passionate about how technology can help bring transformation across industries and help bottom billion. Upcoming, Prasanna is excited to share his experience on AI and IoT in smart cities. Welcome, Prasanna. Stage is yours.
Thank you, Eric. Thanks for the wonderful introduction. So very good morning, good afternoon, good evening, all. So in today's session, our focus is going to be on 4 important stories. And today's session is grouped around these 4 stories. So in the first story, we are going to look at the story of a street light. And in the second story, we're going to look at a story of a thinking street light. And in the third story, we're going to look at the story of the parent of the thinking street light. And at the end, we will look at a story of a thinking city. So let me start with a story of a street light. So we have come a long way in terms of street lights. Olden days, we used to have candles being used as a street lights to advanced technologies being used as part of the street light ecosystems now. And before we understand how the street lights have evolved, I would like to split the whole journey of the street light into the story of the street light into 3 categories. The first category is a pre-2000 era, where what happened to the street light before 2000s and what happened to the street lights after 2000 and till today, taking the consideration of we are in 2022, and what happened to the street light in the last 2 decades. And in the third category, I'm going to look at what will happen, what is going to happen to the street lights moving forward beyond 2022. So that is the whole context, and that will set the expectation and the detail for how things are going in the smart city and the smart home and the smart world environment as such. So before I give you the context of how the whole ecosystem of streetlights have evolved, I'm going to just give you a basic stack of what an IoT stack typically looks like. A typical IoT stack consists of 3 basic layers. You could be talking about multiple layers, but all of them can be grouped into these 3 basic layers. One is a perception layer, and the network layer, and your application layer. In the case of perception layer, if your street lights, assuming that they are enabled with devices, sensors to actually start communicating the capabilities of the street light, then it becomes a smart street lights. You call it as a sensors in the IoT world. And there could be some devices that you will be using in terms of controlling these sensing devices. They are called actuators. And you have multiple street lights. And if you want to have these multiple street lights communicate to your backend system, you have something called gateways. And at the end, you have some kind of a backend application that basically takes care of the sensing and actuation devices. So this is pretty much a very high level stack that you can look at from a typical IoT stack perspective. So what happened to the stack from an AI and IoT perspective till the early 2000s? If you look at IoT in the city infrastructure, predominantly your street lights were bare normal street lights, and specific to the network layer you had some kind of gateways or controllers. They were also not that smart, and you had a high level technology in terms of connectivity. 2G was the connectivity technology around that time. That too, the 2G was not predominantly available across many parts of the world. And you had the city monitoring center, which basically comprises of how do you actually monitor the whole infrastructure, specific in this case, the street lights. And if I look at how AI were applied, typically around early 2000s, there were no AI in the city street lights. And in the connectivity or the gateway layer, also there was not much of an AI. But there were a little bit of analytics done at the monitoring end, at the city monitoring end. So this was the predominant case early 2000s. So let me move forward from early 2000 to till now. What happened to the same city infrastructure, where the whole ecosystem of IoT and the AI in the city infrastructure happened in the last 2 decades. And you had your street lights, but still not much of an AI being applied. But in the last 2 decades, there were a lot of lighting based communication technologies have grown in the actual ecosystem. And you had the gateways that are becoming smarter in terms of there were a little bit of a smartness being introduced part of the gateways, and there were emergence of 3G and 4G technologies there. And your data center side, or the monitoring and the control center side, becomes a little bit more smarter, in sense there were AI being applied in a very very specific use cases. So if we look at the application of AI, and we see that there were not much of an AI being done at the sensors, that is at the basic lights area and street light area. But in the case of your gateways and controllers, there were little bit of AGI started coming in. And the smart city monitoring and the control stations typically had a good amount of AI being applied. So this is we can consider the current state of the actual things that are happening in the street light as an example. So let's move forward beyond 2022. How do we see things are happening? And this has started happening in different buckets, but we see an emergence of something called AIoT, and we have a name called thinking machines. So what is this? What is the stack will basically look like? The emergence of AIoT. So instead of IoT, basically the AIoT is actually making a lot of stride in this space. So AIoT basically enables your street lights as from a smart street light to a thinking street lights. And the connectivity technologies are becoming from a smart connectivity technology to a thinking connectivity technologies. And from a gateway layer, we see that the gateways are getting much, much smarter. Beyond smartness, you have a thinking gateways and controllers in place. And emergence of 5G enables AI being applied on the connectivity technologies. And your city monitoring and control stations are becoming much more smarter, beyond smarter, to a thinking city monitoring and control station. We see that AI being applied across all the layers of it. Okay, so in this first story, what we looked at is how the AI is evolving and how the IoT and the street lights are evolving. Okay, we looked at how from a smart street light to a thinking street lights have evolved or arrived. So now let in the second story, I'm going to talk about what is this thinking street light. What defines that a street light as a thinking street lights? Okay, so here comes the basic the life cycle of what you call as a thinking street light. So the basic difference that we see is you have any device that you wanted to enable with a basic internet connectivity, and it can actually take some of these properties and share it to the backend system. It becomes a smart device. But now, when this device becomes a thinking device, so there should be a definition of when this smart device becomes a thinking device. So that is what we're going to cover. Okay. So now let's take one basic example. Assuming that if a street light detects a malfunction, if a street light detects a malfunction, what happens? Basically, there are two stages of solving this malfunction could happen. So the first stage is where AI can be applied. AI can actually help the malfunction to be sorted out. And the second stage is assuming that AI is not able to solve this malfunction, there comes a manual intervention should be in place. So typically these two scenarios that we are talking about, this exactly is the basic premise of a self-healing AI solutions. So the first premise is the AI itself is going to help you actually solve the problem of self heal the actual malfunction that happens to the street light. And if AI is not able to do, and your actual manual intervention basically helps you solve this problem. So we call it as AI in the loop and human in the loop. So when you want to build any self healing system, and majority of the failures on the self-healing systems, we noted that it was predominantly you only depend on an AI to actually solve the problem. And basically you should have multiple levels of solving the problem, not just the AI, but there should be a mechanism in place so that if the AI fails to actually address that, there should be a human in the loop should be there, not just the AI in the loop. And a coordinated effort of both AI in the loop and the human in the loop basically solves the whole problem. Let's look at end-to-end life cycle and see how this whole ecosystem of self-healing system can be implemented so that a simple smart devices can be made as a thinking devices. Okay, so now assuming that the actual streetlight detected a malfunction, so it tries to solve that problem. So if it is not able to solve the problem, then it raises a ticket automatically to a city authorities. Now the city authorities basically assigns a support engineer to actually address this particular issue. Assuming that for some reason the engineer who has been assigned has not solved this issue, and the street light basically looks for an SLA whether this particular issue that it has raised has it been solved or not. And if it is not solved, the actual street light raises or escalates this particular issue because there is a breach in the SLAs. And this was taken to the city authorities notice, and typically the city authority basically fixes that. And once the fixture is done, the street light now understands that the issue is fixed, and it goes on to the normal loop. So it may be if you are in a corporate environment, for any problem that you face as a human being, you might be doing all this activity. So what is he talking about in terms of street light doing this activity? So that is where the self-healing architecture comes into picture. Okay, so let's look at what are all the challenges in terms of bringing or building such a self-healing system. So there are four important challenges. One is understanding the fault, and if the fault occurred, how do you actually fix that fault automatically using the AI? That is the first problem that we need to solve. And the second problem is there should be an SLA management. So the actual smart devices should understand what is an SLA as such, and based on which it has to actually have a workflow defined, and that workflow it has to actually process that workflow. And in the whole process, it has to understand what stage that particular street light is there. And not just this, for all these activities, there should be an intelligence management should be in place. Okay. So how do we actually approach this problem using AI? So you typically, we call it as a thinking street light life cycle as such. How do you implement a thinking street light life cycle? So we talked about a smart street light. Now, the smart streetlights typically it is enabled with IoT, where it can actually transmit some of the parameters. What is the illuminous value? What is the color intensity? And so all those details on a frequent interval, it can actually transfer the value to the backend system. So that means your devices have become smart. It is not in a thinking, thinking street light. So how do we enable this? So the first thing is the data and the event that are happening in the street light are being processed by a machine learning algorithm. So what is the data? What is the event? The data specific to what is the color intensity is a data. The event in terms of when the street light should be switched on and when it should be switched off. So for our basic understanding, let's take the situation of switching on and switching off. Depend on because street lights has to be switched on when it is dark. So the definition of a darkness varies depend on a season when the darkness happens. So basically, in the summer, you have a longer light duration, and in the winter, you have a less number of light. That is, the amount of sunlight that you get is very less. So you may have to switch on the street light at a very different time. In the case of summer, it could be at 8 p.m. In the case of winter, it could be at 6 p.m. So how do we know that? How does the street light knows that this information? So there should be a knowledge base which actually takes care of this information about, okay, this is we are in this season and we expect the sunlight to go down by this particular time. There are multiple ways you can solve. Either you can even put one more sensor at the street light which can actually detect the light intensity, and based on which it can actually trigger the switching on, switching off, and so on and so forth. There are multiple approaches by which you can solve this problem. So let's assume that we have a knowledge base. That knowledge base has all the information about what happens to the actual street light, whether it is sunset time has arrived, should I switch on, should I switch off. So that our knowledge base helps. And assuming that, let's take a scenario where our street light did not switch on. It is going to be winter season, so 8 p.m. it should switch on, but it has never switched on. So there should be a case that there should be an SLA or a goal for the street light, where the street light should have switched on by 8 p.m., but it has not switched on. So the machine learning will actually wait and process this information that it has not switched on. But there should be somebody who actually has to reason this information. There has to be a requirement for switching on the street light at 8 p.m., but it has not happened. So there should be a mechanism to actually reason this, right? So the insight says from the machine learning that the smart street light should have been switched on at 8, but now the time is 8:30. So the machine learning reasoning will actually look at what is the goal. If the actual street light was not switched on till 8:30, what it should do. So that's where it also looks at the knowledge base and looks at the fact when it should actually switch on that particular light. And it understood that, okay, the light should have been switched on, but it was not switched on by till 8:30. So what is the SLA for addressing this? So assuming that the SLA defines, you wait for 30 minutes. If it is not switched on, an action should be that an optimization step should be that it should try to forcefully switch on. Okay, it tries to forcefully switch on. So that is an optimization step, and that optimization step basically goes back to the actual smart street light. Not just this, and there is a desired KPI that is being defined goes back to the machine learning algorithm. Okay, it should have been done. Can you verify and check and confirm back that the reasoning system will actually request the data from all the systems, could be the algorithm from the machine learning or the knowledge base, and the goals details that are defined in the SLA knowledge base. Assuming that even till 9 p.m. that particular street light was not switched on. So if it is not switched on, then that data is further processed again by the machine learning, and it will give the insight that it is still not switched on. So now that machine reasoning understood that there is an SLA breach on switching on. So it understood that it has to go to the next level because it has already tried the optimization step, but the optimization again failed. That means there could be a mechanical fault that has actually triggered this whole ecosystem. So there has to be a ticket raised to the city authorities so that they can actually address this. So this is the difference I'm talking about. So where basically for the auto self-healing structure that we have defined here will try to actually heal it automatically using the machine learning and the machine reasoning. And if it is not able to do that, as a next step, there should be an approach of a human in the loop should be brought in. So that way you can actually solve the problem that you are actually facing. So in this whole ecosystem of self-healing, architecture, now there is absolutely, for the initial stages, there is absolutely no human is required. So where should all this has to execute? And what we see is an emergence of edge AI infrastructure, where all the things that we are talking about will get executed at the street light, individual street lights. So, how do we actually manage this? So, what we are telling is there is a device which gets, there is a probably some kind of a smart device that gets microcontroller or microprocessor that gets integrated with your smart street light that enables the whole ecosystem of self healing, that brings in or makes the smart street light to a thinking street light. So now this has to be managed at the edge. So there should be a end-to-end management system that takes care of your AI model deployment, monitoring, your reasoning, your ML ops complete workflow, not just for your machine learning models, but for your knowledge base and the SLA knowledge monitoring, and how well the reasoning is actually performing. You have to actually continuously monitor from remotely how the whole ecosystem on the edge is performing. So this is the thinking streetlight life cycle, a self-healing life cycle that we see. Right. So let's look at where we see you understood that in terms of thinking streetlight. How do we extrapolate this information in terms of the whole ecosystem of smart cities? Let me take this and extrapolate it in terms of a smart street. I'm going to call it as a thinking street because each and everything that we are going to have will have an element of self-healing part of the whole ecosystem. And we start with a thinking home, assuming that whatever that we talked about on the street level or at uh, the street light level is getting expanded to your house. All that in your house is currently automated, and each and every devices has their self-healing mechanism in place, SLAs in place, and the knowledge base in place, and manages separately. And a combination of a thinking home brings in a thinking street. And the thinking street could have a multitude of different use cases part of them. It could be a thinking water management, it could be thinking quality management, it could be thinking security management for the street, thinking energy management. There is a multitude of things that you can bring to build a thinking street. And from the thinking street, that's where we bringing the thinking machine framework. Your thinking home and the thinking streets are basically forming the base for your framework, where a combination of multiple thinking home and thinking street brings in a thinking district, and multiple thinking district brings in the thinking city. A multiple thinking cities brings in a thinking region. A multiple thinking region brings in a thinking country and a thinking world. So that is where we see that we are going in the future. Okay. So how should we approach this? When you talk about a thinking city, how should we approach this? So we typically start with a basic definition. There are so many use cases that you looked at. It is a thinking water meter, thinking energy monitoring, thinking security systems, and so on and so forth at a street level, at a district level, at a city level. So now, how should we look at it? So we always start with something called a goal for your thinking city. The goal could be multitude of goals could be there part of your ecosystem, but we start with some basic definition of a goal. So now here in this example, let me take people's happiness index. How happy are the people in the city as one goal? You have to basically translate this thinking city's goal to a business metrics, and from the business metric you have to derive the operation metrics, and based on the operation metrics you have to come out to the use cases which are going to solve your problem. So let me take this example as people's happiness index. There could be uninterrupted power supply could be one area where you should focus on, or quick medical emergency response could be another area people would want, so that their happiness index goes up. Now there could be 100 different other parameters. Just for an example, I've taken only two. Now, how do you translate this to an operation metrics? Now, you should look at when it comes to operation metrics, how can you achieve the business metrics of uninterrupted power supply, where you can look at having an alternate source or cross grid power, or you can use ease of bill payment. And in the case of a quick medical emergency response, you could have 10 minutes as the operation metrics for a response time. So once you define the operation metrics, then you look at how can you achieve that from a use case. So you look at implementing thinking energy management, and in the case of emergency management, you implement thinking emergency management, so that the thinking emergency management, not just the smartness but also the self-healing part, integrated part of it, that is what brings in the thinking energy management and thinking emergency management. This is just an example to help you understand how to actually approach this. Okay, so hope you understand when it comes to a smart city or a thinking city, how you should actually approach. So till now, what we looked at is in the first story, we looked at how the evolution of your streetlight happened over a period of 2 decades and where we see in the future. And in the second story, we looked at how a thinking streetlight structure and the approach should be, and how we can extrapolate the thinking streetlights approach to a thinking city or thinking country and so on and so forth. Okay, so in this third story, let's look at the parent of the thinking streetlight. The parent, nothing but the tech behind it. Before I wanted to talk about the tech behind it, let's look at some of the challenges the actual tech brings in. Okay, some of the challenges the edge AI faces as such. Now, it is expected that over a trillion IoT devices will be available in 2030. There is a lot of change in what is the definition of an IoT device. It is continuously evolving as we speak. Uh, let's look at what are the challenges and how various technologies were addressing them. So there are three important challenges that I see. One is AI models, and I'm sure that all the AI enthusiasts who are part of this conference understand that on a daily basis there is a growing complexity on the AI models that are getting built, and there is a diversity of AI models that are getting built. And in the case of edge AI perspective, you need to have a mechanism of processing at a very high end data at the edge, and you need to have an inferencing capacity at the edge, and you need to have an capacity to actually process the data at the edge after it is done the inferencing as such. And in the case of a scalable deployment, that is also another problem. I'm going to quickly look at two important providers who are solving the AGI problem. One is NVIDIA, another one is Intel. So NVIDIA has their stack of Jetson software stack that actually solves the problem of edge, where these are multitude of devices that are being provided from NVIDIA. The size of these GPU devices, where the size of your credit card, and that can be integrated with any of the smart city infrastructures. And another beauty is part of your ecosystem of NVIDIA comes with something called TensorRT, where you have multiple ways through which you can actually develop the machine learning models. And TensorRT takes care of optimizing this and deploy to any of the edge devices that you are planning to do that. It could be PyTorch, TensorFlow, doesn't matter, and you can actually create your model, process it with TensorRT, and take it forward. And in the case of Intel, Intel brings in OpenVINO, and OpenVINO also has a similar approach of optimized performance at the edge, where you can build your model at any layer, and it can be taken to the next level for any of the Intel devices there. So that is at the edge. And AI in the connectivity part, how it is disrupting. The 5G brings in a lot of scope for AI to play a large role. And 5G brings in a feature called slicing, where you can control the network distribution based on AI. And apart from that, you have self-healing networks and AI-infused connectivities, were all being controlled by AI as such. So let's look at IoT platforms as such. So we looked at Edge AI and the 5G connectivity and the IoT platforms. There are over 600 plus platforms which are predominantly available in the market, out of which if you take the top 40 plus platforms, majority of these platforms already support some form of AI as part of their whole ecosystem. So till now, what we looked at is in the story one, we looked at how a street light has evolved. In the story two, we looked at how a thinking street light has to be done. And in the third story, we looked at the parents of the thinking street lights, where all the technology behind it. So if I want to implement the whole thing as a reference at a city scale, how do I do it? So that is where your reference architecture comes in. So, thinking city reference architecture. There could be multitude of services. There is a connectivity, and there is a sensing infrastructure, and your data warehouse or data lake platform for your data management. In the case of a service layer and AI service management, and the channels that you use for your delivering the services. Predominantly, all the places that we see that AI plays a very important role going forward. And some of the beauty of the whole structure is we are seeing it is not just enabling the city, but the city intelligence as a service plays a very important role, where city can look at monetizing their actual infrastructure and the details on enabling various services to be provided for end users there. Okay, so that brings the four stories and the end of the slide, where we looked at what is a street light and a thinking streetlight and the parent of the thinking streetlight, and how the thinking city reference architecture looks like. So I this is my LinkedIn, and I'm happy to connect with you all. And that's the end of the slide, and I'm happy to answer any questions you guys have got.
Great to have you with us. Thank you very much for this excellent presentation. We do have some time to go through some audience questions, and then we can actually choose the winning question. So From the audience, we received quite a few questions. Thank you very much for to everyone for participating. There is one here um, by Jim Avalos. It says, how can you say that a city is a smart city in global standard? What are the must-haves to consider it as globally acceptable gold standard?
Right. So it is evolving case as we talk about. Uh, See, the definition of smart city is evolving as we speak. Okay, and if you ask me what is a smart city 5 years back, the definition is different, and what is the smart city now, the definition is different. So that's where I'm coming. So 5 years back, the definition was predominantly if you had some of the devices, for example, waste management could be an example, or your energy management could be an example. So from a waste management perspective, you had waste bin, which are dead bins which are there, and if you can actually IoTize and understand whether the waste bin is full or not, so that becomes a smart waste bin. Like this, you choose multiple use cases based on your city's requirement. That is where I defined an approach of what is the goal that the city wants to actually achieve, and based on that goal, and the actual use cases that you use for implementing would completely vary. Okay, and there are like hundreds of use cases that you can look at and start implementing. But in case of a definition there, 5 years before, it is predominantly if you enable a waste bin with an IoT device, and it talks communicating about what is the level it was filled, that defines that you have made it as a smart waste bin, and your smart city infrastructure currently has a smart city solution. But now if you ask, if there is a problem happened in the waste bin, can it solve it automatically? So that is what defines a smart city now. Okay, it is evolving as we speak. Hope I answered the question, Eric.
Did and now I have to ask this question on your knowledge based on your professional assessment. Which city in the world do you think would hold the title of the world's smartest city?
Right, so I would answer it in a two ways. Okay, Um so I would connect the actual answer that I told just now, where the smart city as the definition is evolving. Okay, so if you look at from the older definition, the Western world, is succeeds, where Paris and many of Tokyo and many of the Western countries like Netherlands has Amsterdam, and many of the European countries have done phenomenally well in terms of implementing smart cities. Okay, and if you define on the current state, the smart cities or thinking cities as we call it, and in that standard, I would say Middle Eastern countries are, because they have started investing on such in the recent past, and we see a lot of such gets such initiatives. They're not smart cities, they are going towards a thinking city as a solution. As I'm sure some of you might have heard about a line project from Saudi, and there are very many initiatives in terms of in terms of Dubai municipality, and majority of the Middle Eastern countries have started implementing such initiatives. I'm currently from Saudi, so I'm currently representing from Riyadh as such, presenting. So
You have the answer. That was a must ask question. Thank you very much for that. Now let's jump to choose the winning question. So from the questions that you have on the panel on the right side of the screen,
right,
those are
plenty.
questions. Choose one.
Thank you very much, guys. And um, so now there is a question in terms of um, how would cloud downtime be accounted for in the adoption of AI in the smart city? Uh, when you think about a smart city implementation, this is from Simon. I'm sorry, I'm reading it the name wrongly. SK Marquette. So when we look at implementing these smart cities, basically we do not look at them whether it is cloud dependent or on-prem solution. So if you look at many countries, for example, you talk about Saudi Arabia, there is no hyperscalers here. There is no Azure, or GCP or your AWS part of here in Saudi, where majority of the smart city implementations were at on-prem level. So there is no possibility of downtime of cloud. Is part of the whole ecosystem as such. So that could be in an approach. I mean, that's a very good question that you can take, Eric.
So we have a winner now. Thank you very much for sharing your questions. And well, unfortunately, time is short, and we have to say goodbye to you. Prasanna, I just want to once again thank you for your time. Thank you for sharing your knowledge with us, talking about smart cities and giving your insights. To the audience, I will once again remind you that we have the networking lounge where you can share your opinions, your insights, and any comments that you like. Prasanna, thank you very much for your time and effort.
Thank you very much, Eric. It was a pleasure, and thanks for all the WowAI team for a wonderful sessions. Okay.
Stay tuned, everyone. We still have more to go. We have a panel that is going to be very interesting. So I'll see you there. Bye bye.